Hey, so I just wanted to give a quick walkthrough of Dijkstra's algorithm because it gave me a lot of trouble the way that this problem is set up when I took it. So the instructions say complete the given table, the routing table using Dijkstra's algorithm to find the shortest path from source node B. So B is going to be our source node, and we're going to find the shortest path to all of these nodes. Enter the cost of the predecessor node in the cell in each cell in the table below, 5B. So that would be the cost, and then the predecessor node, that's going to be for C, as you see here. Use lowercase for letter nodes. Enter a dash line if the cost is infinite. So if we're unable to reach the node, then we'll enter a dash. Break any ties alphabetically. I don't know what that means. If the distance to a node does not change in iteration, okay, so enter the previous distance. So if we already have the shortest distance, then don't enter the new distance, basically. But yeah, we'll go through it. Enter the tab key if you can't reach these cells over here. Okay, so if we're starting at node B, we're initializing at node B. What's the cost and the predecessor node of getting to node, or the getting to node A? So we're at B. A is over here. Our cost is 7. Our predecessor node is going to be B. So I'll write 7B, right? Okay. If I want to get to B, I'm already at B, so the cost is going to be 0, and I don't need to enter a predecessor node. To get to C, the cost is going to be 5, and the predecessor node is going to be B. So moving from B to C. D, that's going to be 3, and the predecessor node is B, so 3B. E is, where's E? So that's going to be 8B. And then F, looks like we can't get to F yet, so enter a dash if the cost is infinite, so I'll do that. Okay, so now we're going to go to our next node and fill out the row for that. And we're going to choose the node with the lowest cost. And that's going to be D, so 3B, that's the lowest cost. So I'll put D there. And if we want to move from D to A, we have two possible. If we want to move from B to A, we have two possible routes: from D to A, from B to D to A, or from B to A directly. And the one with the lowest cost is going to be the one that we're going to move forward with. So so it was previously 7B, but now I'm looking at D and all of its neighbors, and I see that I can add a 2 to this 3, and my weight would be 5 instead of 7. So I'm going to add that as my new shortest path. So that's going to be 5, and my predecessor node is going to be D. B, same thing, it's 0, because we're finding the weight from B to B, which is 0. C, so that's going to remain the same because 7 plus 3 is more than 5, so I'll write 5B. D is going to be it's going to be the same, so 3B. E is going to be the same because we can't go from D to E, so I'll write 8B. And we can't get to F yet, so I'll write another dash. Out of these, so I did D, I've done B. What's my next lowest cost? On an alphabetical order, it's going to be A. So now I need to find the path from A to A. That's 5D. And then 0. C is going to be, so I'm going from A to C. That's going to be the same. 5B. D, so there's no shorter path to D. 3B. E, no shorter path to E, so I'll just fill in the previous length. And then I'm at A, right? So I can go to F now. So which is shorter? So that's 5 plus 3, 7 plus 3. So that's going to be a cost of 5 plus 3, which is 8. And our source node is going, or our predecessor node is going to be A. So 8A. And so I've done A, I've done B, I've done D. So the next one is going to be C because it has the lowest weight. So going from C, I'm not going to update my costs for looks like anything And yeah, I have nowhere else I can go. So I'm just going to fill in this row based on the previous row. 5B, 3B. Okay, I've done A, I've done B, I've done C, I've done D. Now I'll do E because it's in alphabetical order. Um, so from E, do I have any shorter paths to anywhere? 8 plus 9 is not going to be a shorter path to D. Is this a shorter path to C? No, 8 plus 3 is more than 5. So it looks like I'm going to do the same thing that I did with C and just fill in the row. 5D, 0, 5B, 3D. Okay. And now finally F. So is there a shorter path to get to anything? So it costs 8 to get to F, right? Yeah, 8 to get to F, and then one more to get to E, but that's going to be 9. So it seems like we don't have any shorter paths, so I'm just going to fill in the row again. 0, 5B, 3B, 8B, 8A. Use your answers from question 1 to complete the following routing table at node B. So this is going to be the cost to get to each of these nodes and the direction that we're going to be heading. So instead of using the predecessor node, we're going to make a choice. Okay, so if we're going to go to A, then our shortest path to get there is going to be to D. So if I go down to the routing table, so the cost is going to be 5, right? 5 in total. So 5, and my next hop is going to be D instead of the predecessor node. So if I want to go to C, my next hop is going to be C because I just jumped directly there. That's the fastest path. So I'll do 5, and then C is going to be my next. Yeah. If I want to get to D, then D is going to be my next hop, and the cost is going to be 3. If I wanted to get to E, then it would just be directly to E, and that's a cost of 8. So 8, E, and then F. If I want to get to F, my next hop is going to be, let's see, so it's going to be D because I'm going to go from B to D to A to F. And that's my lowest cost. So my next hop is going to be D, and the cost of that is going to be 8. And I'll just get it. See if I got that right. Okay, so it looks like I got that right. Yep. So that's how you do Dijkstra's algorithm.